Hi everyone and welcome back to physics. Today we're going to continue our discussion on tools of physics and we're going to do kind of a review on counting significant figures. It's the exact same as to what we did in chemistry, so if you hated it then, again, you're still going to hate it now, but it should be a review for you. So let's recall from last lesson what we discussed. Every measured number has a specific amount of significant figures that tells us the precision of the measurement that we are going to be taking, or that was taken. All of the measurements have a specific amount of certain digits. Those are the ones that everyone's going to get. They're all going to be the same, plus one uncertain digit. The uncertain one is the one at the very end that we use to estimate. And frequently in physics problems, we want to determine the number of significant figures in a measurement performed by someone else. That'll tell us the precision of their measurement. So, you should remember our Atlantic and Pacific rules, or at least using the Atlantic and Pacific rules. You may not remember how to use them, but it should come back to you in some way. So, there are other rules that you can talk about, but these two just kind of narrow it down and make it a little easier. So, if the decimal is present, what you're going to do is you're going to start from the Pacific side of the US, of course, the Pacific side of the number. So Pacific, present, P and P, you're welcome for that. And you're going to place a dot over the first non-zero digit, and you're going to continue your arrow from left to right. So if we take a look at 27036, that's 0. You're welcome for that. So we notice that our decimal is in fact present. So we're going to start our arrow coming from the left side. So we're going to look at it from this side. Again, here's the creepy eye. You're welcome for that drawing. Start looking at the number from the left side. We're going to place our dot over our first non-zero digit, and we're going to continue our arrow towards the right, and we count all of the digits underneath that particular arrow, and we've got 5 significant figures. Hopefully that was kind of a refresher for you. So let's try these examples. So we take a look, see it for all of them, our decimal happens to be present. So we're going to come from the Pacific side. So we're going to look at all of these numbers from the left to right. So we're going to place our dot over the first non-zero digit, and we're going to draw our arrow and continue it from left to right. And we count 1, 2, 3, 4, 5. So this number has 5 significant figures. Let's take a look at the next one. We have our decimal, it's present, so we're going to place our dot over the first non-zero digit and continue from left to right. And we count 1, 2, 3, 4. So we've got 4 significant figures in that variable, or value, I should say. Next, our decimal is present. We'll place our dot over our first non-zero digit. Again, our non-zero digit means any number other than 0, so numbers 1 through 9, or digits 1 through 9. So we count 1, 2, 3, 4 significant figures underneath that arrow. And then last but not least, our decimal, it is in fact present. There it is. So we're going to place our dot over our first non-zero digit, and we should have 3 significant figures here. So this should be a review for you in terms of counting significant figures. So what I want you to do now is actually pause the video and try questions E through H on your own, and then restart the video once you're done to see what the answers are. So you should have paused the video and tried these on your own. So I'm going to go through the answers relatively quickly. Shouldn't take that long. So you should have here 6 significant figures. For the next one, you should have 5 significant figures. For the next one, 4 significant figures. For the last one, the world's tiniest arrow on the face of the earth, there it is, so itty bitty, 1 significant figure. If you got any of those wrong, what I would suggest you do is that you rewind the video and go back and see what you may have missed. If you got all of those right, let's move on to the next part. So now, what happens if our decimal is not there? So remember, when our decimal is absent, we're going to start from the Atlantic side of the number. In other words, we're going to look with our creepy eye from right to left. So if our decimal is absent, you're going to look from right to left, or from the Atlantic side of that number. You're going to place your dot over your first non-zero digit that you encounter, and you're going to count the number of digits underneath that arrow as you continue from right to left. So here, if we take a look, we have no decimal. It is absent, so we're looking from right to left. We're going to place our dot over the first non-zero digit that we encounter. So we're going to continue our arrow from right to left. So here, we should have 3 significant figures. So let's try some example problems, or some more example problems. First, if we take a look at all of them, all of our decimals happen to be absent. So we're going to look at all of these numbers from the Atlantic side, or from the right side. So here's our creepy eye. Bam. Now, we're going to place our dot over the first non-zero digit that we encounter. We're going to continue our arrow in the direction in which we were looking, so from right to left. And we've got 4 significant figures. Taking a look at the next number, we notice that there's decimal that is not present, so it is absent. Look at the number, we're going to place our dinky little arrow over the 2. That's our first non-zero digit, so we only have 1 significant figure. Taking a look at 80-50, looking from the right side, so coming from the Atlantic side, we place our dot over the 5 and continue towards the left. So we've got 3 significant figures. And then last but not least, the decimal is absent, so we're coming from the Atlantic side, so we're going to place our dot over our first non-zero digit and continue our arrow in that particular direction, so we only have 1 significant figure for D. So what I want you to do now is pause the video and try questions E through H on your own. Once you're done with E through H, come back to the video and we will discuss how you got the answers. Hopefully you paused the video and you tried those on your own. What I'm going to do now is go through the answers relatively quickly. If you got any of these wrong, what I want you to do is go back in the video and see where you may have gotten hung up. So let's take a look at this. Decimal is absent for all of these, so for every single one, we're going to use our creepy eye and we're going to look, that's a really creepy eye, we're going to look from right to left. So for E, relatively simple, place our dot over the 7, continue the arrow towards the left, we have 3 significant figures. For 4,000, we should have 1 significant figure. For 273,000, we should have 3 significant figures. And for 94,298, which is a very specific number, we should have 5 significant figures. Okay, so those are our answers. If you got any of those wrong, please make sure that you go back in the video and see where you kind of got hung up a little bit. Last but not least, let's talk a little bit about counting numbers. Counting numbers are numbers that represent something that is specifically counted. They're said to have an infinite number of significant figures. So basically what we're saying, if we have 16 students in this room, the number 16 has an infinite number of significant figures because there's no uncertainty in the measurement. It's not like you have 15 and a half students or 16.2 students. You have exactly 16, hopefully. Unless, you're zoning out, in which case we can get into some decimals. But anyway, so an example of a number that is counted would we have 20 pennies. Exactly 20 pennies. Every person that's going to count that is going to get 20 pennies. So that's said to have an infinite number of significant figures. If we take a look at rabbits, because they multiply like rabbits, but if we take a look at them at one brief instant in time and we say we have 500 rabbits, at that instant every single person is going to be counting 500 rabbits, which would take you a long time because they don't really stop moving. That's said to have an infinite number of significant figures. So now what I want you to do is, I know we have a couple more notes that we could possibly take, but we're going to actually push that to another video. What I want you to do now is flip to these particular worksheets. They're back to back, I believe. So on the top part, what I want you to do is take a look at these numbers and tell me the number of significant figures in the following numbers. So take a look and see if the decimal is present, if it is not present, which side you come from, and so on and so forth, and just give me that number. So if we take a look at number 1, it shouldn't be so bad. We've got the decimal present, so we come from the Pacific side, coming from that side. Boom, we have 1 significant figure. Taking a look at the bottom portion, though, it says, determine the location of the last significant place value by placing a bar over the digit. For example, it's 1.700, so they place the bar over that one. So the last significant one. Okay, so 804, the last significant place value would be the 4. Why? Because when we're counting sig figs, the decimal is absent, so we're actually coming from the right side, so that significant portion of that number happens to be 804, so the 4 should have the bar over it. Okay? So just be careful, take that into account, and then when you're done, we can go over this worksheet. And I will see you for our next video.